Take a seat. Come forward.
So time to start. Okay, good evening. My name is Seok Lee at the Electrical Engineering Department. I would like to introduce Professor Walter Bradey. Professor Bradey is now a distinguished professor at the Baylor University in Mechanical Engineering Department. He was the department chair of the largest engineering department in US, and he directed the university's Polymer Technology Center. Dr. Bradey received his PhD in material science and engineering from the University of Texas at Austin. And he authored more than 125 publications in material science and engineering. And he co-authored with the Jackson and Olson a seminal work on the origin of life, titled The Mystery of Life's Origin, reassessing current theories. He is also a fellow of the American Society for Materials and the American Scientific Affiliation. He was also Educator of Year Award. He received the Educator of the Year Award from the Society of Plastics Engineers this year. His talk will be, is there scientific evidence for the existence of God? For those who actually need a Korean translation, please take the receiver so that I can try to interpret this lecture. Please welcome Professor Bradey.
Thank you.
Thank you.
Thank you. It's a pleasure to be here this evening. I'd actually visited KAIST in the past, but it was in 1988 when it was still in Seoul. One of my former PhD students, Soo Nam, was professor of material science, and I think eventually was vice president of KAIST, although he recently retired. And so it's my pleasure to come and visit KAIST at this location for the first time. Let's see if we're advancing the slides. In 1992, a rather interesting cover story on Time magazine presented a very interesting question: what does science tell us about God? And I think today there have been a number of books written by militant atheists who would claim that science tells us that there is no need to believe in God, that we can explain everything in terms of natural laws or natural principles. What I want to do tonight is to explore whether in fact the things that we see in the natural world suggest a world that just happened, or do they suggest a world that has all of the impressions, the evidence of a world that was in fact intelligently designed? The article in Time magazine in 1992 was probably the first major article to recognize what for 40 years had been a developing discussion within the scientific community. Because I think there were many people who thought that the more we learn in science, the more we make belief in God quite unnecessary. And I think it was quite surprising in the second half of the 20th century for people to begin to see that actually what we were discovering in science, rather than giving the impression that there wasn't a God, was gradually giving the impression that there almost had to be a God because of what we saw in nature. So what I'd like to do this evening is to go through 6 different areas where I think this kind of evidence is accumulating. And if you're interested, I have a much longer book chapter. It's about 33 pages long that we can send out by email to those of you that would be interested. Professor Farnhacker, should we, maybe at the end of the lecture, we can have a paper with a pad, and people who would like this can simply provide their email address. And then you can get more of the details. So what I'm going to give you tonight are the highlights of a much longer story, and then leave it to you to explore that more on your own. Let me begin with a very important disclaimer. One cannot scientifically prove or disprove the existence of God. God is if there is a God, God is a primary cause, and science only deals with what are called secondary causes. So let's agree at the beginning that we will not claim to prove or to disprove the existence of God this evening, but we will look at the universe and say, what does the nature suggest? Does the universe appear to be designed or a result of a series of natural accidents or maybe coincidences? Okay, so here are the 6 areas that I want to discuss in the brief time that we have together. Big Bang cosmology, the mathematical form that nature takes, the fine-tuning of universal constants, the remarkable requirements for the initial conditions, planet Earth, a highly improbable home in a very inhospitable universe, and finally, the amazing origin of life. So let's begin with the Big Bang Theory. If you go back to the beginning of the 20th century, the most widely accepted theory of the universe was the so-called steady-state theory. And in the steady-state theory, it was assumed that the universe has always existed. It did not begin, but has eternally existed. It also assumed that the universe was eternal in extent. Now this solved 2 problems for a person who would want to be an atheist. It first of all got around the problem of the first cause. If the universe began, then the question is, what was the first cause that produced this first effect? A universe that has eternally existed resolves the problem, or avoids the problem, of what was the first cause that brought the universe into existence. Also, a universe that has existed for eternity, is infinitely large, resolves some of the improbability issues that we see as we look at the universe today. In 1929, a new theory was proposed based on experimental evidence. Now, I think most of you have heard of the Big Bang Theory. This term was originally given by opponents of the Big Bang Theory, and it was a term that was meant to be a derisive term, a term that was making fun. It said, who can imagine a universe that began in a Big Bang? How stupid is that? How crazy is that? So the original term was actually meant to be one of ridicule. The evidence went like this. If you looked at the universe in any direction, it was moving away from planet Earth. And if you think about how can the universe be moving away in every direction, it was hard to imagine how this could happen. But picture a balloon, if I were to have a balloon this evening, and if I put black dots on the surface of the balloon, and then I begin to blow the balloon up, as the balloon expands, what happens to the dots on the surface? They become farther and farther apart from each other. As the balloon gets bigger, each dot is moving away from its neighbor dots. And this is exactly what scientists were seeing. So the idea of the Big Bang was born out of very compelling evidence from astronomy, and it explained how a universe could be, if I'm on one of those dots on planet Earth, and And every place I look, things are moving farther away. It's like the surface of a balloon that is expanding with time. So this was the original idea of the Big Bang. It was hypothesized then if you imagined a balloon expanding in time, you would have to say if we went back in time, all of that matter and energy must have been at one place at one point in time. And so the idea was that the universe was born in a fiery explosion of raw energy, electromagnetic energy, and as it expanded and cooled, it began to condense from energy into matter, as in Einstein's equation, E equals mc squared. And so all energy and matter was basically created, energy first and then matter subsequently, to the Big Bang. The universe in this model is also finite in duration. And as we look today, with what we know from astronomy, we might argue that the scientific evidence would claim that the universe is quite old, but it had a beginning and it has a finite lifetime. It also would say the universe is of a finite size. If you picture the expanding balloon is not infinite. So the universe in the Big Bang model is both finite in time and finite in space. In 1965, background radiation, which had been predicted by the Big Bang theory, was discovered. And with the discovery of the background radiation, you can think of it as the afterglow of this dramatic explosion. The afterglow was actually detected. And I think almost universally, scientists were required to accept it. Between 1929 and 1965, many scientists resisted the Big Bang theory, not because of the evidence, it was far superior, but because they did not like philosophical implications. Okay, so what are the philosophical implications of the Big Bang? Stephen Hawking, a famous cosmologist from Cambridge University, in his book A Brief History of Time, says, so long as the universe had a beginning, we could suppose it had a creator. Now, Hawking's position was the universe maybe could have existed eternally. He's trying to convince himself that's possible with some rather very speculative ideas in this book, which he later retracted. But he was anxious to show that the universe has not eternally existed, because if it's eternally existed, it does indeed imply a creator. You cannot have such a huge first effect without some cause. You don't just have a Big Bang happening when there's no energy, no matter, no anything, and then out of nothing comes something. There has to have been a cause. And Stephen Hawking understands very well that the Big Bang is a very theistic implication. Robert Jastrow, a famous astronomer, the first director of the Goddard Space Center, a professor at Columbia University, gave a very famous talk in 1977 for the American Association for the Advancement of Science. Probably the most prestigious scientific meeting in the world. As a plenary speaker, he was invited to speak on whatever topic he thought would be interesting. And he chose the topic, God and the Astronomers, much to the surprise of the people who organized the conference. Robert Jastrow is himself an agnostic. He does not have any particular religious belief. But in this talk, he basically argues that the evidence for the Big Bang was quite superior to the evidence for the steady-state theory from 1929 to 1965. But that scientists were reluctant to accept the Big Bang because they did not like the philosophical implications. In the concluding paragraph of his talk, which was later published in a book, and the book is called God and the Astronomers. It's probably in your library. It's a very famous book, and it is essentially that speech. You can read this very interesting book in 1 hour because it's about the length of the speech. But here's what he says. For the scientist who has lived by his faith in the power of reason, the story of the Big Bang ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. As he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. Isn't that hilarious? He said scientists never expected that what they learned in science would ultimately point them toward God rather than make belief in God quite unnecessary. He goes on in the book to say it's quite interesting and maybe coincidental, but the description given in Genesis 1:3 is actually a rather accurate description of what happens at the Big Bang. In Genesis 1:3, God says, "Let there be light." And the Big Bang Theory basically says, quite to the unintuitive, that the universe began in an explosion that was only electromagnetic radiation and energy, and then later condensed into some matter. If you were thinking the way that most people would think, you would think that you can't begin with energy, you have to begin with what? Matter. It was only after Einstein postulated and it became accepted that E equals mc squared, the idea that you could begin with energy and get matter was completely something that was almost unimaginable. And so the idea, that the biblical idea that God created light and from that comes matter, and the universe as we know it would have seemed quite fantastic. In a later interview with Christianity Today, Dr. Jastrow, who by his own indication is an agnostic, says, astronomers now find that they have painted themselves into a corner because they have proven by their own methods that the world began abruptly in an act of creation to which you can trace every star, every planet, every living thing in this cosmos and on the earth. And they have found that all of this happened as a product of forces they cannot hope to discover. A rather amazing admission by a person who is himself a very famous scientist and also a very honest scientist. So let me summarize the evidence from the Big Bang Theory in this way. Scientific evidence overwhelmingly supports Big Bang cosmology, and Big Bang cosmology supports theism or theism, and completely contradicts atheism. Okay, the second kind of evidence I want to look at this evening is the mathematical form the universe assumes. Mathematical form the universe assumes is one of the most remarkable characteristics of our world. Copernicus, Galileo, Kepler, and Newton, if you know your history of science, the four most important scientists at the beginning of modern science, all wrote admiringly about our orderly mathematical universe. They believed that God designed the universe and it was to be expected that all phenomena of nature would follow one master plan. The universe was orderly and thus described by mathematics because God fashioned it that way. It is the orderliness in nature, in fact, that makes it possible to describe it with mathematics, and not the mathematics that makes it orderly. Differential equations have no power to command nature, but they are good ways of describing nature. Okay? What was initially a very interesting observation by scientists became an overwhelmingly amazing confluence of understanding by the middle of the 20th century that all of the fundamental laws of nature can ultimately be written on one side of one sheet of paper, so small in number and so simple and elegant in their mathematical form. Now, if you look at the diversity of observations in nature, one would not expect the universe to be so tightly organized, so concisely organized, to have this form that people would not have expected. If you think of the elliptical orbits, for example, that we see in the planets as they move around the sun, the idea of an ellipse was developed by the Greeks about 2,000 years ago, and it was only a mathematical abstraction. Kepler was quite astonished to discover that nature actually follows the pattern of an ellipse, an abstract mathematical form being manifest in nature. If you look at these 5 laws, Newton's law is expressed as the Hamiltonian equation, if you know mechanics. Electrodynamics, electricity and magnetism, Maxwell's equations. Statistical mechanics, the second law of thermodynamics, Boltzmann's equations. Quantum mechanics, described by Schrodinger's equations. General theory of relativity, Einstein's equation. These 5 fundamental laws of nature are the basis on which essentially everything else is built. And what is remarkable is that if any one of these characteristics, and I'm going to call the mathematical laws, characteristics of the natural world, you can show very simply that if any one of these characteristics was not a part of nature, that life as we know it, or life of any imaginable type, would be essentially impossible. So it's not just that nature has a mathematical form that's amazing. What's more amazing is the specific mathematical form that nature has is extraordinarily required to make it possible for complex conscious life to exist. Eugene Wigner, a Nobel Prize-winning physicist, in a mathematical journal in 1960, entitled The Unreasonable Effectiveness of Mathematics and Physical Science, says the following: the enormous usefulness of mathematics is something bordering on the mysterious. There is no rational explanation for it. The miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. Albert Einstein, in one of his most famous quotations, said the following: the most incomprehensible thing about our universe is its comprehensibility. He goes on to explain that we would have expected a universe that was chaotic. Who could have imagined a universe that is so tightly organized and so beautifully described by mathematics? A universe that has those characteristics is not the kind of universe that one would have reasonably expected. And yet, that's the universe that we have. A universe that is so mathematical, and yet the mathematical form it takes is so elegant in its simplicity. The fundamental laws of nature each represent, in their mathematical form, characteristics of nature that are absolutely essential for life. Why does the universe have this form? As Einstein said, it's one of the most incomprehensible things about our universe. How could the universe possibly have this form? And the obvious implication is that it has this form because somebody who has a very mathematical way of thinking about things created it in exactly the way that we see it. Okay, let's consider a third kind of evidence. We've talked about the Big Bang, we've talked about the mathematical form that nature takes. Let's talk about the universal constants. When I talk about universal constants, there are at least 19, and some physicists would say maybe as many as 30, that are essential. I like to think of the constants as scaling factors. They define the proportions of different processes and forces in nature. If I were to design an automobile, for example, I would not want an engine that has 1/10 of 1 horsepower of energy. Would you agree that would be too little energy? You push on the gas pedal and nothing would happen. But at the same time, I would not want an automobile with an engine that has 100,000 horsepower. If I had an engine of 100,000 horsepower, what would happen when I touched the gas? I'd take off like a rocket, right? It would be impossible to control. So when you design something, you have to get the different components proportioned to give a proper function. And as we look at nature, I like to think of the universal constants as those scaling factors that are equivalent to what engineers do when they're designing various things, trying to get everything to be proportioned in just the right way. The speed of light, Planck's constant, Boltzmann's constant, the unit charge, the gravity force constant, the rest masses of the neutron, the electron, and the proton. You can look at these and say, why are they what they are, and what difference does it make? Now in the 1950s, here's what scientists thought. In 1950, scientists thought if we had the speed of light as 2 times 10 to the 8 meters per second, what difference would it make? And the thinking was that the universe would be slightly different, and life would be slightly different to be appropriate for that different universe. But when we were finally able to develop cosmological models of the universe, what we discovered was that the values for these different constants are actually extremely sensitive to the characteristics of nature that are essential for life to exist. Let me give you one simple example, which there are many. There have been about 200 examples published in the last 40 years. I need the energy from the sun to match the chemical bonding energy in organic molecules if we're going to have life. Life requires energy. The sun is the way we have as our primary source of energy in nature. But I've got to have that energy be exactly right. If in fact the energy from the sun, the photons of energy, are too energetic, they will destroy organic molecules and life will be impossible. On the other hand, if the photons of energy are not energetic enough, they will not allow the necessary photosynthesis to occur. So I actually have a fairly small window. I don't want the energy to be too great, but I also don't want it to be too small. Now, for the energy of the photon of radiation from the sun to be sufficiently large to facilitate chemical reactions, but not so large that the photon destroys the chemical bonds of carbon atoms in organic molecules, I need for that to be matched to the visible light that is radiated by the sun. There are different constants that control the radiation from the sun and control the quantum mechanical bonding energies in organic molecules. You can actually express this in the following way: for a star to emit a spectrum of light which has its highest intensity for wavelengths of visible light, which is the right wavelength for organic molecules, I must satisfy this equation. I need to satisfy it in a particular way. I'm going to have the term on the left must be bigger than the term on the right. But I want it to be, I have an approximate sign here, which is to say they should be the same order of magnitude. So it's not good enough to have it just be bigger than. There's a threshold I need to be above, and I don't want to be above it too much. Notice in this inequality, I have things raised to the 12th power, to the 4th power, squared, squared. This is a very, very nonlinear algebraic equation. Here are the 6 universal constants. Now, what's the probability of getting 6 different universal constants that have exactly the right values to satisfy an equation like this in the way that's required? Extremely unlikely. Okay, if you go back to the table that I showed a minute ago, I don't know how to go back to this, so we won't go back. No, let's just skip that. Okay, so if we go back to this equation, take the constants, plug them into this relationship, we find out that we have 5.9 times 10 to the minus 39 for this. And we have 2.0 times 10 to the minus 39 for this. Notice that this term is bigger than this, and they are indeed of the same order of magnitude. Now here's the question. What is the probability that these 6 different universal constants would all happen to have exactly the right relative values to allow energy from the sun to be exactly the right magnitude to provide the necessary photosynthesis without destroying organic molecules? And this is an amazing example, but there are like 200 different examples of exactly this type. Colonel Ken Zies, Nobel Prize winning Nobel laureate in physics, says, "Astronomy now leads us to a unique event, a universe which was created out of nothing and delicately balanced," what we've just been talking about, to provide exactly the conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest and underlie, one might say, supernatural plan. Okay, let's talk about a fourth evidence, a fourth consideration. We talked about what? Big Bang, the universe that began. We talked about what next? The mathematical form that nature takes, and the very specific fact that it's mathematical is the first interesting observation, is the fact that the specific mathematical form is very critical to allowing life to exist. And then the fact that the universal constants are exactly what they need to be. There's actually a term for this, it's called fine-tuning. If you Google search fine-tuning, you'll find many, many different things that have been published on this idea of a universe that's very, very carefully and precisely tuned to make it possible for life to exist. Okay, the fourth type of evidence has to do with initial conditions. Most of you in here probably have taken a course in differential equations, is that right? Graduate students at KAIST. When you solve a differential equation, the form of the solution often depends on what? Boundary conditions, right? The initial conditions. So it turns out that in the origin of the universe, one of the critical requirements is that the initial conditions have to be very precisely prescribed. In Scientific American in 1999, they had an article talking about the problem of these initial conditions having to be so specific. Here's what they gave as two examples. There are actually more. The ratio of the gravity potential energy and the kinetic energy, the instant after the Big Bang, must be equal to 1 part in 100,000. If the expansion after the Big Bang is too rapid, it will expand so quickly that the gravity is not able to cause condensation of different hydrogen and helium to form stars, which then produce the heavier elements. So we could have had a universe that was just rather empty, with only low-density hydrogen and helium. Alternatively, if it were too slow a velocity, the universe could expand briefly, but the gravity force would be sufficiently strong, it would cause it to recollapse rather quickly. And so what we need is a universe that's very delicately balanced between too rapid an expansion, which leads to no suns or planets, no stars or planets, or a universe that just exists for a short time and recollapses, which again is not a universe where life could exist. 1 part in 100,000. More recently, they have determined, cosmologists, that the two components of the expansion driving cosmological constant must cancel to 1 part in 10 to the 123rd. I think most of you know scientific notation to realize this is a very, very difficult requirement to meet. And there are many different places you can go to find details. In the paper I'm going to make available, I actually have some good references. But the one that I took this out of was a Scientific American 1999 article. Stephen Hawking quips, why is the universe so close to the dividing line between collapsing again and expanding indefinitely? If the rate of expansion 1 second after the Big Bang had been less by 1 part in 10 to the 10th, the universe would have collapsed in a few million years. If it had been greater by 1 part in 10 to the 10th, the universe would have been essentially empty. Now, why is his number different than the last one? In the last one, we were talking about what? Energy. In this example, he's talking instead about velocity. What's the relationship between velocity and kinetic energy? 1/2 mv squared. Okay? So you can either say we need to specify the energy to 1 part in 10 to the 5th, or the velocity to 1 part in 10 to the 10th. But this is one of those mysteries about how things happen or why they happen exactly the way they do, why it's hard to imagine how all of the initial conditions were exactly what they have to be. If they're slightly different one way or the other, we simply end up with a universe where there's no life. Now let's go to the remarkable conditions about planet Earth. As you look in the solar system where we live, or is there any place you would rather live than the planet Earth? What's the problem with Mercury and Venus? Way too hot, right? What's the problem with Jupiter? It's gaseous. Would you like to live on a planet that was nothing but gas? It's also quite cold. As we look around our universe, our solar system, I should say, we have 62 different planets or moons. But none of those provides the conditions that would be necessary to support life. In 2000, a couple of scientists from the University of Washington, both of these fellows are agnostics. As you can tell, and I'll show you in a quote in a minute, and I know people who know them well. They term rare earth, why complex life is less common in the universe. Now in this book they try to speculate on, is it likely that life could exist in other parts of the universe, or is there something really unique about planet Earth? And they begin by saying, well, there's probably going to be planets in conjunction with other stars, there's lots of other stars, there are many other places where life might exist, surely some of them must be okay. But as they go through the book, they very carefully point out, the more we understand about what's required for life, the more difficult it becomes to explain how you got all of these conditions. As if it were a design problem, we might have, for example, 30 or 40 different requirements, and every one of those has to be satisfied. Let me give you a couple of examples. I need to have water, but not too much water. I need to have heavy elements to give radioactive heating at the center of the Earth, because that radioactive heating is what actually allows the crust of the Earth to be soft enough to allow plate tectonics. Now why do we need plate tectonics? Because without plate tectonics, the surface of the Earth would be like a cue ball. Do you know how to play pool? Okay, if the surface of the Earth were like a cue ball, guess what? If you have any water at all, it would be too much, right? What makes our planet habitable? We have higher places and lower places. If it was all smooth, and if we had 10 feet of water, we would all drink. So plate tectonics is crucial. The properties of the silicate in the crust of the Earth have to be just right to match with the thermal heating of the radioactive nucleation in the center. We've got to have just the right amount of water, not too much, not too little. They go through 250 pages of different things that if any one of these were not as it is, the Earth would not be a place that was suitable for life. Now late in the book they conclude this. If some godlike being, notice they're not people who believe there is a real God, but they say if some godlike being could be given the opportunity to plan a sequence of events with the express goal of duplicating our Garden of Eden, that power would face a formidable task. With the best of intentions, but limited by natural laws and materials, it is unlikely that Earth could ever be truly replicated. Too many processes in its formation involve sheer luck. Earth-like planets could certainly be made, but each would differ in critical ways. Isn't that an interesting comment? This is a really, really interesting read if you're interested in how many other places are there where life might exist, and is it possible that maybe we'll someday have visitors from outer space. But in this book, even though these guys are both agnostics, you don't think there's a God, they nevertheless conclude that there's almost certainly no other place in the universe that got it just right. And the very fact that we have it just right here is itself a remarkable accident, requiring, as they say, sheer luck. Okay, finally, our sixth example I want to do briefly is the origin of life. And if we can, in just a second, turn off the lights. I want to show you a short video clip, and then we will talk briefly about this.
For years since Baylor's rejection of chemical evolution, science has revealed the details of an entire system of information processing that bears the hallmarks of intelligent design. With computer animation, we can enter the cell to keep this remarkable system in order. The heart of the cell, we see the tightly wound strands of DNA, storehouses for the instructions necessary to build every protein in an organism. In a process known as transcription, a molecular machine first unwinds a section of the DNA helix to expose the genetic instructions needed to assemble a specific protein molecule. Another machine then copies these instructions to form a molecule known as messenger RNA. When transcription is complete, a slender RNA strand carries the genetic information through the nuclear pore complex, the gatekeeper for traffic in and out of the cell nucleus. The messenger RNA strand is directed to a two-part molecular factory called a ribosome. After attaching itself securely, the process of translation begins. Inside the ribosome, a molecular assembly line builds a specifically sequenced chain of amino acids. These amino acids are transported from other parts of the cell and then linked into chains often hundreds of units long.
Here's the protein
Their
that's made.
sequential arrangement determines the type of protein manufactured. When the chain is finished, it is moved from the ribosome to a barrel-shaped machine that helps fold it into the precise shape critical to its function. After the chain is folded into a protein, it is then released and shepherded by another molecular machine to the exact location where it is needed.
This is absolutely mind-boggling to perceive at this scale of size such a finely tuned apparatus, a device that bears the marks of intelligent design and manufacture. And we have the details of an immensely complex molecular realm of genetic information processing. And it's exactly this new realm of molecular genetics where we see the most compelling evidence of design on the Earth.
Briefly mention what we were saying. We began with what? DNA. Everybody's familiar with DNA. DNA opens up and allows you to form a molecule that's called transcription RNA. The RNA molecule then allows you to be able to put together a whole sequence of amino acids which provide proteins which control all of the sort of enzymatic activities in the body, okay, or in the living system, whatever it happens to be. Okay, Kenneth Miller and Joseph Levine, in their biology text, probably the most popular college biology book used in the United States, 1998, although the books more recently say much the same thing. The largest stumbling block in bridging the gap between non-living and living still remains. All living cells are controlled by information stored in DNA, which is transcribed in RNA and then made into protein. This is a very complicated system, and each of the three molecules requires the other two either to put it together or to help it work. DNA, for example, carries information but cannot put that information to use or even copy itself without the help of RNA and protein. As you look at the origin of life, it's very, very difficult to imagine how you can independently create these necessary molecules that work together as a unit to be able to do the necessary functions for life, processing energy, storing information, and replicating. I think today it's widely accepted that all of the current ideas are woefully inadequate. In December 9th of 2004, the newspapers and the TV news shows that evening all reported a rather remarkable and surprising event, and it was headlined in the following way. One of the world's leading atheists now believes in God, more or less based on scientific evidence. And here's basically the story. A British philosophy professor who has been a leading champion of atheism for more than half a century has changed his mind. He now believes in God, more or less based on scientific evidence, particularly having to do with the origin of life, and says so on a video released on Thursday. At the age of 81, after decades of insisting belief is a mistake, Anthony Flew has concluded that some sort of intelligence or first cause must have created the universe. A superintelligence is the only good explanation for the origin of life and the complexity of nature, Flew said in a telephone interview from England. This would be sort of analogous to Billy Graham coming out and declaring that he's now become an atheist. Can you imagine how shocked we would all be, those of you who know who Billy Graham is? We would say, gosh, Billy Graham has become an atheist? How is that possible after being such a dynamic Christian for all these years? Anthony Flew was one of the three most influential atheistic philosophers of the 20th century. And for him to decide at this stage of things, I might add, as far as we know, he did not necessarily become a Christian. So this was not a decision that was made for fear of what happened after death. It was a decision based on the overwhelming evidence that he found from science and support. One of the ways Flew found this was he often debated his atheistic position, and in the last 20 years he was getting beat over and over and over again badly based on scientific evidence. And he finally said, you know, I think these other people are actually right. Now let's suppose you go home for a holiday in the period of November, and as you drive into your driveway, the tree in your front yard looks like this. And as you look at this more carefully, if you're a young lady, you say, gosh, the tree actually gives the impression of a portrait of a girl. Here's her lips, her nose, her eyes. Here's her very fashionable hairdo. And as you look, you might say, my gosh, it's not just any girl. This looks like me. Now, what would be the possible explanations for this? Okay? One possibility is it's just a fluke. It's a complete accident. Is it possible that the leaves could all fall off the tree to leave this impression of exactly your face? The answer is, well, of course it's possible, but is that likely? No, this is really quite ridiculous. Would you agree? So let me give you some other possibilities. Somebody picked the leaves off this tree very carefully. They did not fall accidentally. And they left behind the ones to give this portrait of somebody's lovely daughter. It could have been a loving father, it could have been a mischievous brother, it could have been a secret guy admirer who was trying to get your attention. Somebody very carefully harvested these leaves to leave behind this impression. And as we look at the universe, this is exactly the kind of a problem that we have today. Because when you look at the universe, you have to say, how is it that so many different things all had to be exactly right, or we end up with a universe unsuitable for life of any imaginable type? Is it possible that all of this happened as a result of hundreds of cosmic accidents? Well, that's possible, but that's not really rational. You would call that putting chance in as the god of the gaps. The more we look through the eyes of science, using our microscopes and our telescopes and the much sophisticated instrumentations available today, the more we see a universe that is remarkable in every possible way. The Apostle Paul, writing in the first chapter of Romans, says, evidence for the existence of God is clearly seen in the things that have been made, so that those who do not believe are without excuse. Now, that may have been true in some sense in Paul's time, but I would argue that today it is overwhelmingly true that what we see in nature makes it almost inconceivable that the universe that we have could have been the result of accident, and of life in that universe as well. Let me conclude by saying that intelligent design is not primarily an alternative to evolution. Some people think it's intelligent design or evolution. No, there's actually a much, much bigger and more interesting story, which we talked about tonight, that has nothing to do with evolution one way or the other. I happen to be skeptical that the mutation natural selection can explain everything that we see in the diversity of life. But quite apart from that, the real, to me, compelling evidence is what we see in the universe that began, rather than eternally existed, in the mathematical form that nature takes, in the universal constants, which all are exactly what they need to be. They've got 200 different examples to be able to produce a universe suitable to support life. In the initial conditions, which are so blooming specific, and yet are exactly what they need to be. In the remarkable requirements for planet Earth, which our planet uniquely meets, I believe, not just in this solar system, but in the universe. And then in the amazing requirements for the origin of life. There are many other things, but I think these are 6 tremendously interesting examples. So I would say that intelligent design is not an alternative to evolution, it's an alternative to a materialistic worldview. The worldview that says that there is nothing in the universe except energy and matter, and that somehow energy and matter organized itself in a very, very amazing and unique way to give us the remarkable universe that we have. I do not find that to be a rational explanation. Intelligent design claims that natural processes alone are inadequate to explain the complexity and wonder of the natural world. To believe in an intelligently designed universe requires much less faith than to believe in an accidental universe. Most of my career in the United States, I've taught in public institutions where most of my professional colleagues, not most, but at least many, were agnostics or in some cases atheists. And they would often tell me it takes a lot of faith to be a Christian. And I would say it does take some faith. But it's not an irrational faith. There's actually a good bit of basis for believing that Christ was who he claimed to be. But then I usually reply, it takes a huge amount of evidence to be an atheist, though. I don't know how you can do it, you know? To believe all of these things happened in some completely accidental way requires an amazing amount of faith. I don't know how you can possibly do it. Now, I want to share with you a final video clip that illustrates this point, okay? Y'all know this movie, Dumb and Dumber? Have you heard of this before? Okay, if we can turn the lights off one more time, listen very carefully, and then I'll make the point that's being made in this movie. Okay?
I want to ask you a question.
It's interesting because I find a lot of my friends who want to be agnostics or atheists are very much like the guy in Dumb or Dumber, because no matter how much evidence there is to the contrary, no matter how bad the odds are, their response is what? Well, there's still a chance. It may be 1 in a billion or 1 in a trillion, but, well, great, there's still a chance, right? And I think that when we look at the evidence today, we need to be honest and say the evidence overwhelmingly supports a universe that did not happen by accident. There are way too many fingerprints of designers to not see that as, I think, the most rational outcome. Now, let me conclude with what I said at the beginning. This is not attempting to prove the existence of God. It's more to say, let's look at nature and say, what does it suggest? What seems more reasonable based on what we know today in current science? Okay? So why don't we open it up for a short Q&A period? We won't be too long, but let's open it up for questions and comments if some of you would like to ask questions. There are a lot more interesting details, and these will be provided in the 33-page book chapter that I've had published with about 100 references. Okay? So let's open it up for questions that some of you might have. Yes, over the back.
I have a couple of questions, but what does this say the Big Bang is unique and that it's not a frequency of expansion and contraction, or that it's unique in that it's the only one that's ever happened where there's no parallel universes or other universes that exist besides the one that we know?
Okay, it's a terrific question. Let me begin with the first possibility, an oscillating universe. And I think the idea of an oscillating universe was proposed after 1965 when the background radiation for the Big Bang was discovered. And the basic idea, for those of you that aren't familiar with this, is maybe the universe has eternally expanded, had a Big Bang, expanded, recontracted, bounced again, and expanded many, many times. There were several articles published in Nature magazine in the 70s evaluating this whole concept. And let me illustrate the nature of the comparison. If you take a so-called superball, do you know what a superball is? It's one that bounces completely elastically. And you drop the superball and it bounces and it comes back up, essentially to where your hand was. So no energy was dissipated in that bounce. What you would need to have a bouncing universe would be a similar process that in fact is doing this but with no energy dissipation. Now, we all know that explosions are inherently very, very energy dissipating. And so you can do some relatively simple thermodynamic calculations which were done and published in Nature magazine and about several different well-known scientists that simply demonstrated that we aren't going to have a bouncing universe. It may bounce once and then do this, but it can't bounce for some infinite period of time. If you're trying to reclaim the idea of a universe that has eternally existed, you can't do it with a bouncing universe because the explosions of a Big Bang are inherently energy dissipating and it doesn't work. Okay? Now, we talked about what's the possibility of having other alternative universes, and I think the multi-universe theory is something that has also been proposed as a way of trying to overcome this fine-tuning problem. And the idea is if I had millions and millions and millions of universes, in fact they would say maybe 10 to the 500, then maybe I could get these things right by having enough tries. Okay? There are two problems with this. The first problem is with the multi-universe, it's absolutely impossible for us to ever see outside of our current universe. There are fundamental physical laws that say whatever this is, it's a mathematical model which may describe real universes outside of ours, but there's no way to know. It's just a mathematical model. So in some sense, it's not science in the traditional sense of being able to be validated with real empirical data. But the second problem is it doesn't really get around the fundamental issue here. If you do the kinds of modeling that are done for the Big Bang, it basically requires differential equations with many very carefully prescribed constants to make it work to give this multi-universe. So I simply substitute one problem for another one. Okay? I talked about the mathematical form and the universal constants here. For the universe we have, you say, well, but suppose we had many universes. Fine. The multi-universe theory itself requires mathematical equations and very carefully chosen universal constants exactly the same. So I've simply substituted, or I've sort of replaced this problem with one level down. So I don't think it actually solves the problem at all. But I think it's basically been developed as a mathematical possibility to try to explain around the things that we're talking about.
Is it improbable that it exists? Or other universes exist? Is there any evidence against another universe existing, or is it just that we don't know, so therefore...
Well, I think it's
we can't
impossible
say?
to ever know experimentally. It'd be the same question you'd say, is there scientific evidence God doesn't exist?
Well, mathematically, you said that it's proven, or possible.
Well, I'm saying you can make a mathematical model to predict almost anything that you want. I can create all kinds of imaginary realities using math, which may or may not correspond to real physical reality. Okay? So I'm saying that the absence of evidence doesn't prove it's not true. It simply says we can't know. It becomes a statement of faith, much like I think the statement of faith that a Christian has, that what I see in the universe I think implies to God. It doesn't prove that God exists. Okay?
And along with the mathematical model, the way you're describing the mathematical model, it seems that you could predict the movements of the universe, much like you could predict the movements of billiard balls on a pool table, to where you set it up once and give it an infinite or a large amount of energy, and you could predict all those movements. Is that correct?
It's not exactly correct, because I think one of the fundamental issues when we talk about any origin story is, where does the energy come from in the first place?
Well, I'm talking about now, though. After it's been hit, to where you can predict the movements from understanding or observing all of the energy within the universe. It's sizing down the universe to billiard table.
I think this goes back to something Laplace said many, many years ago when he tried to say we can just use pure classical mechanics to sort of, if we know the conditions at some point in time, right? We can predict the future of everything.
Yeah.
But I think that's a very classical view, which with quantum mechanics and relativity no longer really applies. It applies to certain limited sets of problems. But I think the Big Bang cosmology is very much a theory that depends on more modern physics than just the classical mechanics.
Well, even if we were able to acquire all the mathematics and all of the data describing every single piece of the universe, could it be predicted of what will happen next? And a fate type of matter. I guess this is a fate versus a free will type of question, to where is the universe fated to a single destination, or is there room for chance or for a veering off of that final destination?
Okay, let me answer this question. We'll give some other people a chance, okay, so we're not just having a dialogue. I think there are two fundamental things that we've come to appreciate in the 20th century that make predictability much more dicey than it used to be. And one of those is quantum mechanics, and the other is chaos theory. And I think both of these have helped us to really understand that the universe is not as simply predictable as Laplace originally thought. Okay? I think today when you talk about quantum mechanics, we're always talking about probabilities. We used to think the universe was simply deterministic, which would be the term for what you're describing.
Yeah.
And today we know that at a fundamental level, the universe is in fact much more probabilistic. And it's much more chaotic. That's why, for example, weather patterns and many things that happen in nature are not simply and easily predictable at all. They're very much stochastic.
So reality can't be modeled by mathematics.
Well, it can't be modeled in the deterministic sense. It can be modeled in the statistical sense. Okay? It's just a different, what I can predict is very different. If you look at the Heisenberg uncertainty principle, it says you can never know the position and velocity of a particle at any point in time with precision, right? So it says, sorry, we can't measure everything and we can't predict it in some more precise way. The universe we used to think of was very hard and simple, and you could kind of do what Laplace was saying. And today we know it's actually much more subtle and much more mysterious, I would say. And I think a lot of people who do quantum physics would agree. An electron behaving like a particle in a way is totally incomprehensible. But that's exactly what we see. Okay, good questions though. Let's have some other ones. Yes, sir.
What's your explanation about the factors cylindrical set and also super pattern algorithms, light gain? The patterns created by those simple mathematical objects are a little bit complicated, and but still they are generated by assembly one line actually. So it seems they have to be designed intelligently. But it's just from one limitation.
So are you talking about algorithms?
Yes.
Yeah.
And also
Yeah, fractals, yeah. I think these are interesting examples of how you can generate rather diverse patterns that are somewhat unexpected. But I don't know that those are today used by anybody to try to explain in some more specific way the specific kinds of requirements that we were talking about here. I think getting some unusual kind of a pattern is different than getting a very information-rich, complex pattern that meets some specific design requirements. And so I don't think that a simple algorithmic kind of a explanation would account for the kinds of initial conditions, mathematical form, and nature text. The examples that I was giving today, I don't think would be accounted for in that sort of a way.
A simple algorithm may not be enough to explain what we see in our universe. We have quantum mechanics, and the same like God is playing dice, right? Unlike what Einstein said.
Now, Einstein said he didn't like the uncertainty because he didn't think God played dice with the universe.
But it seems God is playing dice.
Oh, there's no doubt about it.
So, and it seems there's a huge number of random numbers injected into our universe.
Yeah.
In each second.
Yeah.
And a simple algorithm combined with random numbers.
Can you speak up loudly so everybody can hear? These are interesting comments. I could hear his, everybody could hear his in the back because he was speaking loud enough for me to.
A simple computer algorithm combined with those huge number of random numbers may be enough to explain what you see. What do you think about this?
I don't think that will be an adequate explanation to account for the things that I was talking about this evening. Some people think this may be a way of trying to explain some parts of evolution.
And also there is entropic principle. So we are in this universe thinking why we are here and why we exist next to but it could be that a simple algorithm combined with a huge number of random numbers highly likely that they will give a junk universes where the intelligent life forms are impossible to form. But it's very unlikely, but there can be some universes where simple algorithm combined with a huge number of random numbers give a condition that's enough for us to exist and things about ourselves.
Okay, so you think that the algorithm, and where did the algorithm come from?
Algorithm could be, there can be many, algorithms also, sure. And many computer programs, and let's say one of them, most of them, let's say, are not good enough to generate habitable universe, but maybe some of them is good enough.
Let's assume that there was something like a computer program that had an algorithm. I've never seen a computer program that's functional that wasn't intelligently designed. Okay? So it would seem to me, if in fact what you're saying is possible, it only suggests that that was in fact the way the design was manifest. It doesn't say that you can accidentally have a computer program with an algorithm that does all of these amazing things. That happen. I think the algorithm itself then requires something to account for it. It just pushes the problem back.
Maybe it's just a set of mathematical objects that should be equivalent to between as an algorithm.
Okay. Okay. Other questions? Yes.
So we have a lot of evidence against a reductionist, materialistic view of the universe.
Correct.
So why do you label this intelligent design? It seems like intelligent design might be only one possible explanation for this kind of evidence.
Well, it may only, it obviously is one possible explanation. As I look at the different requirements, maybe you can suggest what some other alternatives might be. Because the only other alternative that I'm aware of is the infinite number, or almost infinite number, of alternative universes.
Right.
Okay?
That would be one explanation.
Yeah. Well, in fact, it's the one that says if you give me enough tries, then the improbable becomes more probable, right? Just increasing probabilistic resources. And that is, in fact, an alternative. I gave you 2 reasons why I don't buy that, but it's the only other alternative that I'm aware of.
Well, that also brings up the question of what the term intelligent design implies. It's very anthropomorphic. So I was wondering what exactly you meant by design, like if it was a design of initial conditions, or if you think of it as more as a kind of a guiding principle.
Let me describe, how many in here are engineering students? I'm curious. Do we have engineering students here? Some, okay, not so many. I thought we had more engineers at KAIST anyhow. In engineering, I would say design and purpose are synonymous. Okay? So when I'm doing design, I'm basically trying to organize a system to accomplish some particular function. So I'm using design in that sense, that if something is designed, it must be something organized to produce some purposeful outcome. And implicit in my description of this as intelligent design is that I believe that complex conscious life is not an accident in nature, but an inevitable outcome that was the result of somebody configuring the universe in just the right way to allow this to happen.
But I don't understand why it has to be a somebody. Why can't it just be a kind of self-organizing principle?
Well, it could be if we could figure out what that self-organizing principle is.
Well, I mean, I would call it spirit. I think it's just...
Well, okay. Let me say that the evidence that I've given does not tell us in detail what the nature of the designer is. You'll notice I haven't specifically tried to say this is the God of the Bible. Okay?
Right.
Because I think that's a question that requires some additional evidence. So I think what I can say is I don't think this is an accidental universe. I think it's a universe that is carefully crafted to produce a purposeful outcome. And we can simply say that could be spirit, it could be God, it could be whatever you would like. But it's something that transcends the physical material universe itself. Okay? And I wouldn't, at this point, you can't take the scientific evidence and try to be more specific about the nature of what that creating force is. So I would accept your argument that maybe there are other possibilities, but I wasn't trying to in some sense, hone in on the Christian God specifically. Let's save it till we've had other chances, and not you, the guy behind you, is wanting to ask yet another question. So let's let other people have a chance, and then we'll come back, okay? Yes?
Our universe seems to be an instant among many experiences. But why another instance wouldn't be also an instance?
Well, I would say if I made an automobile that had the purpose of providing transportation and it doesn't really function, then I would not call that a successful design. I would call it a failed design. Okay? So
that implies previous intention. So that implies a previous intention.
that implies
A previous intention.
a previous intention. No, I'm very much, we could have many, many different universes that are not associated with life. And in fact, if you look around our solar system and look at what we can know about planets with other stars, at this point there are some excellent examples of places that simply don't work, period. Okay? So the argument is not that it's like if I deal a hand of bridge. Do you play bridge? Okay, well, poker? Poker, okay. So if I deal a hand of poker and I get whatever is the best hand, I guess that's a straight flush or something, or maybe it's four aces. I might call that, if that's the hand that is going to guarantee that I win, there are many, many hands that I can deal. And I would call those hands that simply don't work. If I'm trying to have a hand that gives me the very highest possibility of winning, that guarantees I'll win, then there's only one hand that actually does that. And so I'm saying if in fact the universe is the way it is because it has a purposeful outcome in mind, which which is complex conscious life, then it's going to have to meet a bunch of requirements. If you want to just say rocky planet is okay, then it's easy to make those kinds of outcomes. Okay? So there are many what I would consider failed examples of places for life to exist. But if you're not interested in life, then you can say they're just as good as planet Earth. Okay? I'm obviously implying that I think there's something unique about Earth, and the uniqueness is centered in the complex conscious life that exists here, and I think is unique in the universe. Okay? But for that to happen, there were many very specific requirements that were necessary. Okay, RB.
Yeah, I think it's already over 8:45. I'd like to thank Professor Bradey for giving us this.
What's the best way for us to get their email addresses? Do we have a, if you like it, the chapter that explains in much greater detail the basic ideas on how
How about just writing their email address when they work out?
Okay.
Like their email address.
Yeah, if you can write it on a little sheet of paper, just make a pile outside the door.
Right.
Okay.
Yeah.
Okay. Good. Well, thank you for your attention and for coming out this evening and sharing this time together. It's been very enjoyable visiting with you, and I'm happy to stay around for a few minutes to answer more individual questions that maybe you didn't have a chance to ask or were embarrassed to ask in front of all your friends. Okay? So thank you again. It's been a pleasure to be here.
Thank Professor Bradey. We could do two things. One is this Korean souvenir. I don't know what's inside. Must be a good one.